Hi everyone. Today we are going to discuss the nomenclature of steroids and classification of steroids and some aspects of stereochemistry of steroids. First and foremost thing is, what are steroids? So in general, the known alcohols are liquids. So whatever the alcohols which are available at regularly are in liquids, that means they are simple alcohols, whereas steroids are long chain alcohols. So long chain alcohols are always fatty alcohols, fatty in nature. Similarly, long chain acids are fatty acids, whereas short chain acids are what? Simple acids which are liquid in nature. So when you increase the carbon load, what happens when you increase the carbon load? The non-polarity increases, as well as the compound tends to be a solid. This is the first most fundamental. Okay, long chain alcohols are fatty alcohols and long chain acids are fatty acids. Now, what are steroids? See, steroids are available in biological. There are 6 steroids: cardiac glycosides, bile salts. First and foremost thing is, the steroids are hydroxycholesteins. Combinedly are called as steroids. Hydroxycholesteins, combinedly called as steroids, and the terminology was first adopted with cholesterol. So this is the fundamental information of nomenclature of steroids. Steroids means hydroxycholesteins are called as steroids, which are the first classified as cholesterol. What is cholesterol? Cholesterol is a solid isolated upon centrifugation of your bile, that is bile solid. This is the first fatty alcohol or steroid obtained after centrifugation of your what? Bile, that means on the liver. This is the first classification of steroids. Then, what is the basic nucleus in steroids? So, the basic nucleus in steroids is cholesterol. So, what is the structure of cholesterol? Now, I am going to give you the structure of cholesterols. This is the basic nucleus of cholesterol. So how many carbons are available in the basic nucleus of cholesterol? Is 17 carbons. Okay. Now, while you are numbering what happens? The steroids, the pattern of numbering is called as serpentine numbering. Serpentine means it is snake-like. Serpentine means snake. So we will see whether we are correct or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. This is the numbering of your fatty alcohol or cholesterol. This is the basic nucleus, cholesterol. Now, I told you that it is a serpentine numbering. Whether it is correct or not, we will see. Now the numbering is moving like this, like this, like this, like this, again like this and like this. That means the propagation of the numbering pattern is like, you can see, snake. This is the pattern of movement of your numbering. That's why it is called as what? Serpentine numbering. This is the first most information which you get from the numbering. Okay. Now what first we will see the cholesterol. What is cholesterol? So cholesterol is a structure which contains, so the color is not visible, let me change with black. Okay, now you have a hydroxy at 3 position, and this one, and this. Now you have a side chain. Okay, this is the basic nucleus of cholesterol. Now we will see the numbering of cholesterol. What exactly the numbering of cholesterol tells you? So the numbering of cholesterol is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 and 27. So this is the numbering in cholesterol. This type of, and the side chain which is available in cholesterol is isohexyl. Okay, so now you can see 1, 2, 3, 4, 5 and 6 isohexyl. That means the side chain is isohexyl. So this is the fundamental of isohexyl group. This is the present in cholesterol. Now I will give you a sequence of structures with which you can have a remembrance of what the basic nucleus of steroids. Okay, so you should follow them, then only you will be able to remember. If not, again you will forget. So first one is estrade. Estrade contains 18 carbon cholesterol, 18 carbon steroid is estrade. Now next one is androstrate. It is an 19 carbon. Next one is progesterone. It is 21 carbon, and cholesterol is 27 carbon. So this is the, you have to follow a pattern so that this you should remember, and from this let us deduce structures and remember some steroids which are very, very useful. So now if you come to the stereochemistry of steroids, okay, what carbon fusion happens in synthesis of steroids? Okay, let us see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. So whenever there is synthesis of steroids, there is always fusion between 5 and 10, 5 and 10, comma 9 and 11. Next one is 13 and 17. So this is the fusion, synthetic fusion between whenever rings, whenever there is a synthesis of steroids. When you come for the what we say, stereochemistry of steroids. Now steroids, based upon the stereochemistry, that is 6 steroids, cardiac glycosides and bile salts. Now this is ring A, this is ring B, and this is ring C and ring D. And all the carbons of backbones are chiral in nature. So that means what are chiral in nature? Let us check which are the carbons which are chiral in nature. 1, 2, 3, 4, 5 and 6. That means there are 6 chiral centers in cholesterol. So the number of isomers, the stereoisomers, that is 2 power n, that means 64 isomers are possible in cholesterol. So now let us see what is the configuration of CD. Now see, let us see the stereochemistry. Now the in between A and B in 6 steroids, all are in trans, whereas in cardiac glycosides, cis, trans and cis. T for trans. Now in bile salts, it is cis, trans and trans. What does it mean? The fusion of 2 rings, that is A and B, B and C and C and D, all are in trans position. Trans means orientation of your rings. Trans means farther. That means they have a solid nature. So you can expect that these may have low boiling point and have highly solid in nature. They have long melting points, low boiling points. Now if you see this one, molecule exists in 2 cis isotope, like A and B and C and D are fused in cis, whereas the ring B and C are fused in trans orientation. This is the orientation in which they fuse. Okay, this is the fundamental information which you get from the stereochemistry. So the synthesis of steroids in fungi and in animals, they use lanosterol as the precursor for synthesis of steroids, whereas in plants they use cycloaltrinose. So this is the precursors for synthesis of steroids. Synthesis of steroids occur in fungi and animals. It is the precursor is lanosterol, whereas in plants it is cycloaltrinose. This is the precursor. Okay. Now let us see some structures with respect to the nomenclature of steroid. First one is estrane. So estrane is a 18 number steroid. Let us draw its structure. this is what your cholesterol nucleus, that is backbone. Now I said to you it is an 18. This is 17. Now this is 18. So this is the backbone of E strain. So now what is left out? Now this is aromatic in nature, E strain. Now it has hydroxy groups at 2 positions. So this is the structure of E strain. So now how you will write the nomenclature of E strain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So this is the fundamental structure of your E strain. Okay. Now next one, let us go for androsten. Now androsten is 19 carbon. So let us draw the structure of 19 carbon cholesterol. So this is a cholesterol 17. Now 18 carbon 18, and this one is your 19. Now you have a OH here. This is E strain. Okay. Now I have OH here also. Whereas you have to remember that the only aromatic sex steroid is E strain, and the all are non-aromatic. This is the fundamental information which you need to remember. Now this is non-aromatic. So what happens? These 2 double bonds will go to this one, and you have a structure like this. And this one is androsten. You can also name it as testosterone. Okay. So what is the difference between these two? You have one more carbon extra, that is your 19th carbon. So this is the fundamental one extra than E strain, and the 2 double bonds have gone to this one. So this is your androsten. Okay. Next one is progesterone 21. Let us see that one. Okay. 17 carbon, 18, 19, 20, 21. Okay, this is 21. Now earlier you have 2 hydroxy groups in E strain. When you come to androsten, 1 hydroxy is converted into what carbonyl carbon? This one is enone, that is androsten. When you come for progesterone, the 2 hydroxys converted to enes. So that means, so this is your fundamental structure of, this is E strain with 2 hydroxy, androsten with 1 hydroxy, progesterone with 2 hydroxy. That means 18, 19, 20 and 21. So this is 20, this is 21, 17, 18 and 19. This is the fundamental information of your progesterone. Now taking progesterone as a basic nucleus, let us deduce some structures. So first and foremost thing is you need to draw the structure of what? Progesterone. So I am drawing the structure of progesterone. Okay, 17, 18, 19, 20, 21. So this is my progesterone, right? Now I will write structures of cortisol, cortisone, prednisolone, prednisone, dexamethasone, alpha-methasone, and triamcinolone. So this is the different structures which I am going to deduce from this structure. Okay. Now cortisol is a modified structure of your progesterone with 3 changes. What are the 3 changes? 21 beta, 11 beta, 17 alpha hydroxy progesterone is your cortisol. Okay. Now these many 3 changes, if I do on progesterone, I will get cortisol. Let me try. This is your basic nucleus cholesterol. 17, 18, 19, 20 and 21. Okay, sorry, let me have a bigger structure so that I can. Okay, this is cholesterol. 17, 18, 19, 20, 21. Okay, this is your progesterone. Okay, there is no changes. Now I am doing 3 changes on the progesterone to get cortisol. What are the 3 changes? 21 beta hydroxy. Yes, 21 beta hydroxy. 17 alpha hydroxy, okay, and 11 beta. So what are the changes I am doing onto progesterone? 21 beta, 11 beta, 17 alpha hydroxy is cortisol. Now I want cortisol. There is only one change. Convert the 11th hydroxy group to one. So that is the only change from cortisol to cortisol. So do it. This is cholesterol basic nucleus. 17, 18, 19, 20, 21. Now this is having double bond, double bond, double bond. So by what is this? This is only progesterone. So what are the changes I need to do to get cortisol? 3 changes, that is 21 beta hydroxy, 17 alpha hydroxy and 11 beta hydroxy. To get cortisol, there is only one change, that is 11th position will be on, that is cortisone. This is cortisone. Okay. Next one. Now I got cortisone. Now I need to get prednisolone. So how I get prednisolone? Just convert cortisol with one double bond at 1 and 2 position. So to get prednisolone, only thing I need to do is change the cortisol with one double bond at 1 and 2. Do it. This is your basic cholesterol, that is cyclopentanoperhydrophenanthrene. This is the basic, the cholesterol is called as, this is your phenanthrene, this is your cyclopentyl, that means cyclopentanoperhydrophenanthrene. Okay. This is your 17 member, 18, 19, 20, 21. Okay. Now to get progesterone, what I should do? So this is your progesterone. Now to get cortisol, 3 changes I need to do. What are the 3 changes? 21 beta, 17 alpha, and the other one is 11 beta. Now to get, this is your what? Cortisol. Now I am converting cortisol to prednisolone. The only change is double bond between 1 and 2. So if you see these two structures, what is the difference? Only one difference is this is a double bond. Now you got prednisolone. Now how you will get prednisone? Just simple. Convert the 11 beta hydroxy to ketone. So you will get what? Prednisone. Okay. Now from prednisone you can produce dexamethasone, alpha-methasone and triamcinolone. How? What are the changes I need to do on prednisone to get dexamethasone is, that is 9-fluoro, okay, 9-fluoro and 16 beta methyl. That is the 9-fluoro 9-fluoro and 16 beta methyl. If I add this to the what? To the prednisone. So first let me draw structure of prednisone. This is your prednisone. To prednisone, I have to do 9-fluoro and 16 beta methyl. So I will get what? Dexamethasone. So let me do. How I will do? Simple. Draw your basic nucleus of cholesterol first. Okay, once I draw the cholesterol, 17, 18, 19, 20, 21, 21. After getting 21, now I have a double bond. This is your progesterone. From progesterone to cortisol, I have to make 3 changes. That is 21 beta, 17 alpha, 11 beta hydroxy. Okay, cortisol. From cortisol to prednisolone, cortisol to cortisone, only one double one. From cortisol to prednisolone, one double bond between 1 and 2. Now prednisone, now I have to change to the other double bond. Now next one is to get dexamethasone. Now prednisone to dexamethasone, just add 9-fluoro, 16 beta methyl. So that will give you dexamethasone. Suppose if you want to get alpha methasone, just change this with alpha methyl. Beta top, alpha down. This is the only. Now suppose you want to get triamcinolone, simply add OH at this position, you will get triamcinolone. So you have to remember each and every structure so that you can give the nomenclature of steroids in naming drugs. So I guess this is helpful for you in classification of steroids, stereochemistry of steroids, naming of steroids, numbering of what is the basic nucleus? That is cholesterol. It is also called as cyclopentanol perhydrophenanthrin. This is the fundamental information you get from steroids. If you like, subscribe, hit likes, comment, and share among your friends, juniors, seniors, and other college mates. Thank you.